Welcome back. Can't believe you made it back for even more lead coding, but here we are. We're looking at a problem that I haven't attempted before. It's an easy one. Easy problems are nice because they allow you to practice the interview process so that you can refine your systematic approach to them. We're not going to try to write the least amount of code or anything. We're going to be trying to communicate what we do in the best way possible. That's kind of the focus of these type of videos, if you were wondering. Anyway, so yeah, let's have a look at what this problem is and see what it's all about. Step 1, let's read the problem description. You are given an integer array nums. You need to ensure that the elements in the array are distinct. To achieve this, you can perform the following operations in any number of times. Remove 3 elements from the beginning of the array. If the array has fewer than 3 elements, remove all remaining elements. Okay, so that's okay. Note that an empty array is considered to have distinct elements. Return the minimum number of operations needed to make the elements in the array distinct. Okay, so we're given an array and we chop off the beginning of the array, 3 elements per chop. And then we need to stop chopping when all of the remaining elements in the array are distinct. So we don't have any repetitions, I guess. Right. Constraints. Okay, so there's a constraint on the length of the array, and there's a constraint on the values in the array, which we can shamelessly exploit. But let's go through the examples first. Example 1. Okay, so we have an array. Let's see, 7, 5, 3. So I guess we need to chop until here to get distinct elements. Let's see if we can. How would it go if we do the chopping? So we chop these 3, we chop those 3, 4, 2, 3, and then we're left with this. So what are we returning? The minimum number of chops. Nice. Okay, so minimum number of operations. So 2 chops, 2 times karate, and we are done. Nice. Okay, let's look at the second one here. Oh, we need to do a lot of chopping because the last 2 elements are not distinct. We do 1 chop, and then the last operation is to remove all elements because we have fewer than 3. And so we still have 2 chops, 2 operations, and an empty array counts as a distinct one. So we chop the entire array away to end up with a array that's empty and that is considered distinct. Nice. Example 3. So there are no duplicates in this, so we don't have to do any chopping. Right, cool. So, interesting. So how should we approach this problem? Well, so the core challenge is that we need to know when we have distinct values in the array. So I think so this is also always good. So if you've gone through a couple of examples, you can actually implement or suggest the way you went through the examples as the code. And something that we did was we just looked at, okay, from the back of the array, we iterated until we found an element that we've seen before. So why don't we just do that? So we will do that. We will keep track of the elements that we've seen via a hash map. So we're going to need some space to store those. And as soon as we encounter an element that's, or a hash set maybe even, as soon as we encounter an element that we've seen before, we know that we need to have to chop at least to that point. So we could do that. And now in LeetCode, you always have these constraints, but if you want to do runtime analysis, you have to assume that the length is unbounded. Otherwise, everything is automatically constant time and constant space. So let's just assume that the number of elements in the array is unbounded, but also that the values in the arrays are not limited, right? So that means that if we use a hash map to store the elements, we have potentially n elements. N equals the number of elements in the array in total. So if they're all distinct. So let's just write down this the runtime analysis for the suggestion that I just made. So we're going to need, well, we need to iterate through the entire array. So that's going to be O of n, right? So we're just going to say n equals the length of nums. So we're going to have O of n time and O of n space, because there could be at most n different values in nums, assuming that there's no limitation on the different values. And but then once we've identified the chopping point, we probably, we just have to do some math calculation. How many chops we have to do to get there. So that's going to be a constant time operation. So yeah, I think this is going to be our runtime analysis for this problem. So step 1, find the chopping point. Yeah, and we're just going to iterate. Well, first we need our little data structure. And we're going to use a set, and then we're going to iterate over all of the numbers in reverse. Range length nums, and this is also something you need to know by heart, how to iterate backwards in an array. It's very simple. Yeah, just have the 3 minus 1. So this means we iterate from the value len minus 1s, and we stop at the value 0, but because the end is never inclusive in the Python range, that's why you have to put -1, and this is the step size, so we're stepping backwards. Cool. So n is nums at position I. If n in scene, then we know what the chopping point is. Is I, and we're done. And chopping point is 0 in the beginning, right? That means we don't have to do any chopping. Do I put -1? Do I put 0? We have to put -1 because maybe the chopping point is at 0. That means the 0th element is the first duplicate. But yeah, let's see. And then we just put the value in there. So that what should return us a chopping point. And it points exactly to the element, to the last element that needs to be removed. Well, to the last element that needs to be removed in order for the remainder of the array to consist of only distinct elements. So that's the first thing we do. So now we have to deal with the chopping point. So if the chopping point, is smaller than 0, we don't have to do any chopping at all. We're done. And now, if the chopping point is between 0, 1, and 2, we have to do 1 chop, right? So number of chops is chopping point. Is it an integer division by 3? Let's see. Is it that? And when I can't really focus, stuff like this, then I just go into the very details and I just make it very explicit. Depending on your interview form, you can probably see the solution right away, or you might not, but you need to have a strategy of how to deal with days when you're not at 100%. So for me, I have a code right now. I find math as difficult, so that's why I'm going to do it very explicitly, and maybe it also makes the video better. I don't know. But yeah, so if we have a chopping point of 1, 2, or 3, or no, 0, 1, or 2, the -1 means no chops necessary. All elements are unique. But let's say if 2 is the chopping point, that means we need to remove the 2. So now I want, if chopping point is 2, and I do an integer division by 3, I get bit 0, so that's wrong. What if I increase the chopping point by 1? Let's just do that. So if I increase the chopping point by 1, meaning we know it's at position 2 of the array, but we make it one more, then I will get back the correct number of chops, namely exactly one chop. But if the chopping point is at 3, then I get the incorrect number of chops. So that's not the correct approach. Maybe the correct approach is 1 plus. So let's just see. So this means 1 chop, 1 chop, 1 chop. If I'm here, I need 2 chop, 2 chop, 2 chop. Right? So if a chopping point is between 0 and 2, I want 1. If it's between 0 and 2, this integer division gives me 0 and I get 1, which is the correct result. If my chopping point is between 3 and 5, this will give me the value 2, no, the value 1, and we add 1, so it's 2. So I think, yeah, I think this is the correct formula. The number of chops is 1 plus chopping point. And then in the end, we just return the number of chops. Do you feel brave enough to test this now? I think we do. And let's see what happens. Ooh, okay, so that worked nicely on the examples at least. Let me just rewrite this slightly. Is 0 like this. Or we could do it like this, return 0 otherwise. Yeah. Okay. We didn't change the functionality, it should be identical. And let's run, well, let's submit the entire thing and see what happens. Wrong answer, okay. 5 and 5. Output is 0. Okay, so we have a problem when the chopping point is pointing to position I. Right, remember, because we're going to put n, so the 5, into the hash map. Then at the next iteration, when we're at position 0, oh, I see. So we actually have to check if it's equal or larger than 0. I think that was the mistake. Because remember, the chopping point is pointing to the last element that we need to chop. And index 0 is, of course, if we need to chop the first element. So yeah, that was a mistake. In an interview, you want to catch that mistake before you run any code. And there you go. So yeah, so that's a solution. And it's always good practice after you've solved this problem your way to have a look at how other people solve the problem. So I'm just going to look at the Python example. Beats 100%. Nobody cares about that. By the way, if you practice for interviews, you don't really care about the runtime. You care about the asymptotic runtime and space complexity. You don't care how many milliseconds or megabytes of memory your solution took on LeetCode. Delete elements continuously and with a deck. Okay. So this deletion is not a constant time operation, I believe. So this is why this is probably an n squared or something. So that is not a good solution, in my opinion. Let's look at this. Easy. This one uses another data structure as well. And let's see. Minimum operation, what does this do? So it puts all the elements into an extra array and then removes them from the end of the array. until the length of the set of the numbers is the length of the number. So it builds a set every time in the while loop. So that's also not very efficient. This is also a squared solution, really. Come on, there must be something we can learn. We already have off and time, off and space. Maybe there is something with a better space complexity. Slicing and set, I don't know. Okay, this one also builds like a new set every time. Why would you do that? I don't understand. Yeah. Super easy emoji solution. Imports a counter. All of that is not necessary. Try to keep it as simple as possible. And you should be good to go. And when you're in good interview shape, you will spot these things when you step through your mental debugging process at the end. And yeah.